Okay, well, see me after class. I don't have time to take it up right now.
Do you want us to write this on a separate sheet of paper other than the?
No, you can put it on the same notes if you want to. It's all part of gas laws. All right, so Gay-Lussac's law. Probably should be apostrophe S. Now, these are two different people. They just happen to come up with the same law at about the same time, so we kind of give them both credit for it. So from last week, you should know then that P1 over T1 equals P2 over T2.
Is that an L or A?
Gay-Lussac's law is an L. Okay, we're going to use the same problem-solving process. So make a list of knowns and unknowns. Find the correct equation. Start plugging it in. Make a list of knowns and unknowns. Write down your equation and start plugging in what you need.
Will you have to change it from
Absolutely. Anytime temperature is in Celsius, it's got to be changed to Kelvin.
Do you use the same number as the other problem?
Yeah, it's always 273.15. That doesn't change. 273.15. pressure and volume, but this is not, this is pressure and temperature. So here's the equation for pressure and temperature.
Mr. Pettis,
Yeah.
when you round, if there's a zero, do you round after the zero? The zero doesn't count as a space, right?
I'm not sure I understand. Are you talking about one of these two zeros?
No, the 23.0, you know how you have to add 273.1.
Right. Well, that's a significant digit.
Okay.
So you're going to round it off to the 10th place.
And after you add that, it turns in from Celsius to Kelvin,
You have to turn your temperature into Kelvin. You can't use temperature
so
in
I'm saying the units is now Kelvin instead of Celsius.
It doesn't say you have to turn it back, so you don't have to if you don't want to. It doesn't. If it asks for the temperature in Celsius at the end, then you have to turn it back. But if it doesn't ask for it, you don't have to.
My
Well-
question is when I add the 273.15 to the 23 Celsius,
Mm-hmm.
what is going to be my new unit?
Kelvin.
Okay.
I'm sorry. I misunderstood what you were asking about. How do we do? This number here? I have to, you cannot calculate gas laws using temperature in Celsius. You must change it to Kelvin, and the conversion between Celsius and Kelvin, if you're going to change from Celsius to Kelvin, you add 273.15 to that. And so when you round it off properly, you get 296.2. What now? 316.6. Yep.
Alright, the smallest like number in the whole thing, like 3 digits.
Actually, no. The smallest number is 4, because when you do the math here for Kelvin, you get 4 digits, and so all these numbers have 4 significant digits. Okay.
Every time you change it from Celsius to Kelvin,
You have to. Yeah. That's how you convert between Celsius and Kelvin. Okay. Anything else? All right. Now, the chemistry department here decided this year that we were going to change a few things around, and it didn't occur to me until just now that Gay-Lussac's law is not listed on your test references, so I'm going to have to make some changes to your test references. In the meantime, you have your own test references, and on your test references, you should stop right now and put in Gay-Lussac's law. So before the next test, I need to make that change. Gay-Lussac's law is not actually listed on the state standards, but I used to teach it too. It's not that big a deal. All right, so we've got all these laws then. We've got P1 over V1. P1 over T1 equals P2. I'll tell you what, let's stop the video here, capture, and I'll start a new one.